Hello everyone and welcome to class of sending data in Ethernet networks. Today in this lecture we are going to discuss about sending data in Ethernet networks. So IEEE 802.3 Ethernet header and trailer fields. Ethernet data link protocol, it defines an Ethernet frame. So Ethernet head at the front, the encapsulated data in the middle and trailer at the end. So if we see the composition, it has field like preamble, SFD, destination. They are fields, and the numbers which are defined are the total number of bytes that it contains, and then what is their functioning, like preamble. Preamble contains 7 bytes. This preamble is required for the synchronization purpose, which is in the header field. Then we have SFD. 1 byte is consumed by it. SFD as start frame delimiter. It basically signifies that the next byte begins the destination MAC address field. Then destination MAC address, which has 6 bytes, it identifies the intended recipient of this frame. Source MAC address, 6 byte it contains, and it identifies the sender of this frame. Then we have type. 2 bytes are taken by this. It defines the type of protocol listed inside the frame, IPv4 or IPv6. Encapsulated data, which is data in the padding, 46 to 1500 bytes it has. So it holds data from the higher layer, typically an L3 PDU, usually an IPv4 or IPv6 packet. The sender adds padding to meet the minimum length requirement. Padding is there so that it can meet the minimum length requirement, which is 46 bytes. And then we have FCH, which is frame check sequence, 4 bytes. It is in the trailer. It provides a method for receiving NIC to determine whether the frame experienced any transmission errors or not. Let's start with Ethernet addressing. The source and the destination Ethernet address fields, they play a huge and important role in how Ethernet LANs will work. The sender node puts its own address in the source address field and intended Ethernet destination device address in the destination address field. The sender transmits the frame, expecting that the Ethernet LAN will deliver this frame to the correct destination. Ethernet addresses are also called as MAC addresses. They are 6 byte long binary numbers. MAC as media access control, 6 byte, that means 48 bits long. Most computers list MAC addresses as 12-digit hexadecimal numbers. Most MAC addresses represent a specific NIC or other Ethernet port. So these addresses are often called a unicast address. Unicast means one interface to Ethernet LAN. Unicast MAC addresses are always unique. Before a manufacturer can build Ethernet products, it must ask IEEE to assign the manufacturer a universally unique 3-byte code, which is called as OUI. This OUI is organizationally unique identifier. Why we require OUI? The MAC address always begins with its assigned OUI. So, burned in addresses, BIA, it refers to the idea that a permanent MAC address has been encoded to the ROM chip on the network interface card. Group addresses identifies more than one LAN interface card. So, if we discuss about the structure of the Ethernet addresses, like OUI, which is organizationally unique identifier, it is 24 bits, 6 hexadecimal digits, which we can say, or then vendors assigned NIC cards interfaces also there. So Ethernet addresses are go by many names. So we can say we have different LAN address, Ethernet address, we have hardware address, burned in, physical address, universal or MAC addresses. Like Ethernet addresses are gone by these all names. We have broadcast addresses also. Frames sent to this address should be delivered to all the devices on the Ethernet LAN. Multicast addresses. Frames sent to multicast address will be copied and then forwarded to the subset of the devices on a LAN. We have LAN addressing terms also. Under LAN addressing terms, we have MAC, Media Access Control. It is 802.3 Ethernet, which defines the MAC sublayers of IEEE Ethernet. Then we have Ethernet addresses, NIC addresses or LAN addresses. Other names often used instead of MAC address. These terms describe the 6-byte address of the LAN interface card. Burned in address. The 6-byte address assigned by the vendor making this card. Unicast address. This is a term for the MAC address that represent a single LAN interface. Broadcast addresses. An address that means that all devices that reside on this LAN right now. Multicast addresses. On Ethernet, a multicast address implies some subset of all devices on Ethernet. Multicast is some subset of all devices. Error correction detection with the help of frame check sequence. FCS in Ethernet trailer. It is the only field in the trailer which gives the receiving node a way so that it can compare the results with the sender to discover the errors which occurred in a frame. Sending Ethernet frames with switches and hubs. Most Ethernet LANs use a variety of physical standards, but with standard Ethernet frames can flow over these type of physical links. Each individual link can run at different speed, but each link allows the attached node to send the bits in the frame to the next node. They must work together to deliver data from sending Ethernet node to the destination Ethernet node. So if we take an example of sending data, suppose we are having two PC1, PC2 and two switches. The pattern is different in switches and hubs like switch 1 and switch 2. The PC1 builds and sends the original Ethernet frame. It can send using its own MAC address as the source address and PC2 MAC address as the destination address. Switch 1 receives and forwards the Ethernet frame to switch 2. Switch 2 receives and forwards the frame out to the PC2. PC2 again receives the frame, recognizes the destination MAC address and processes the frame. If this process is carried half duplex, the device must wait to send as it is currently receiving a frame. It cannot send or receive at the same time. Whereas in full duplex, it can send and receive at the same time. So if we talk about the hubs, to understand hubs, we have a half duplex logic. Like a switch, a LAN hub provided a number of RJ45 ports. These are the places to connect links to the PCs. Hubs use different rules for forwarding data. LAN hubs forward data using physical layer standards rather than the data link standards that is considered to be L1 devices. When an electrical signal comes in one hub port, the hub repeats the electrical signal out all other ports. So the data reaches all the rest of the nodes connected to the hub, so that the data hopefully reaches to the correct destination. This is the process of sending Ethernet frames with switches and hubs. Thank you.